All right, so let's talk about the graphs of cosecant and secant. If you recall from the graphs of tangent and cotangent, both of these functions are considered reciprocal functions, so they are going to have a denominator that we need to worry about where that is 0, because you can't have those values. It's going to be undefined. So if you recall, the cosecant is defined as 1 over the sine of x. We're going to be looking at all the values where sine is 0 in order to get our asymptotes. So without actually graphing sine, hopefully you guys remember that it's at 0, pi, 2 pi, and we can get all our asymptotes. Okay, now I am going to graph the sine curve really quickly just because there are parts of it that we are still going to use. Actually, I'm going to use the big black dot. Okay, so if I put those points right there and I were to actually connect them. Okay, wow, that's probably my best one yet. What you're going to do now in order to get the curve for cosecant is every place that you have a maximum for your sine and a minimum for your sine, those are special points for your cosecant curve. And what you're probably going to end up thinking of them are as the vertices of something that kind of looks like a parabola, because these are going to be branches that head towards the asymptotes on either side. And they're not actually parabolas, so they don't follow that equation, but they look like them. So they're going to be going up or down depending on which pair of asymptotes you're working with. And that really depends on the max and mins of the sine curve that it's associated with. So as you can guess, this sine curve is going to continue down here. So there's going to be a minimum right there, and then it would continue up and have a maximum right here. So that's where the other branches are going to go. So this is going to go down. You just have to follow the pattern like that, and then this is obviously going to go up. Oops. Oh, that one was terrible, but you get the idea. Okay, now if we were going to have a period change or a phase shift in the horizontal direction, you're going to work on that sine curve first to get your asymptotes. And then if there's an amplitude change or even a vertical phase shift, that's going to affect where these points are. So if you wanted to do the amplitude while you are doing your sine curve, that will help you out in figuring out where your max and mins are. And then if you wanted to think about the vertical phase shift afterwards, after you figured out where your asymptotes are, maybe this point would move up 1 and this point would move up 1, and so on and so forth. Okay, so let's clear this and move to secant. Okay, so here's secant. Now secant is the reciprocal of cosine. So we're looking at where cosine is 0. And so hopefully this seems very familiar. And if I were to draw in the cosine curve, there's a maximum, there's my 0, here's my minimum, here's my 0, and back up to the maximum again. I'm not actually going to draw in the cosine curve, but I will use these max and mins right there, there. The next one is going to be a minimum, and then we had a maximum, 1. Okay, so I'm going to use those max and mins for the cosine curve in order to establish where my branches go. Now, if it's a minimum, remember it goes down like that. And if it's a maximum, it's going to go up. Right? Okay. And then this one's going to go down again. Whoa! Okay. Erase that. That was terrible. Okay, put that back here. Okay, try again. Much better. Okay. And then you have to remember to do the sides as well. So this part is going to go up, and then this part is also going to go up to the right. And there you have it. Okay, so that's what secant curve looks like. And if it helps you, maybe you need to have the cosine curve drawn in here. So remember that this is what cosine would have looked like. Okay, if you want to, by all means, go ahead and draw that in. It doesn't really matter. But if you don't need it, don't use it. Okay, so now let's do one example where I'm just going to throw everything at you. Oh, wait, before we do that, we have to talk about the period. The period for secant and cosecant is going to be the same as the period for sine and cosine, since they really are just the reciprocals of those functions. So you would do the 2 pi over the absolute value of b just like before. Okay, now let's do our example. So if you look, isn't this nice? We have an amplitude, we have a period change, we have a phase shift in the horizontal direction and in the vertical direction. Doesn't that look like fun? Okay, so the first thing that we're going to do is we're going to factor out this 2 so that we can actually see what our phase shift is. We're going to move pi over 2 radians to the right, and we're going to move up 1 unit. Okay, so here's our new period, taking 2 pi and dividing it by that 2, and there's our phase shift. Okay, so let's see, if our period is pi, that means that I have to break up my 0 to pi into 4 equal parts. So I have to include some more tick marks here. So I'm going to go ahead and double up on those tick marks. And then just thinking about cosecant is sine. So sine is going to go here, up here, down to there, and then right there. So our asymptotes right now would be at the 0, the pi over 2, and the pi. But we are actually going to be shifting, what is it? Pi over 2 radians to the right. So I'm going to go ahead and think about pi over 2 radians to the right means that this point is going to move right there. Oh, interesting. It's still in the same location. This point would move right there. Okay, well, it looks like all of our asymptotes are going to be where we naturally thought they would be. Let's go ahead and draw those in. Okay. Now, the other thing that I wanted to concern myself with, and I don't want to forget about, is the fact that we have this amplitude of 2. So maybe instead of rising this up to 1, what I'll do is get rid of that, and maybe I'll take this up to 2 and down to -2 instead. Okay, because now with the red curve, remember the red curve is supposed to be the shifted curve, this point is going to move pi over 2 radians to the right. And then this point has to move pi over 2 radians to the right. And then this point would move pi over 2 radians to the right. Okay, so I am going to go ahead and draw in my sine curve here. Starting right here, I'm going to go all the way up here, come all the way back down, all the way here. Woo. Okay, so there's my sine curve, such as it is. And you can kind of see with the pattern that this would come down to here, right? So we would, let's just finish that off and go like that. Not my best drawing. Okay, because this is now what we're going to be using to think about where to find our max and mins, right? So here's a maximum, there's a minimum. Those are the ones that we're going to use for our branches. However, remember that we are shifting 1 unit up. So whereas this blue dot would typically be the vertex of our branches, we actually have to shift that up 1 unit. So it's going to go right there. And then this point right here normally would be down here at -2. I don't know where the negative sign went, but it's down here at -2. We're going to move that up 1 unit. So it's going to go right there. Okay, so let's go ahead and draw those in. So this is going to get drawn down. And then this is drawn down. Okay, this one's going to get drawn up. Ooh, that did not look good. Let's try it. Whoops, let's get the eraser. Okay, what happened to my dot? Here's my dots. And let's see here, let's try this again. There, that looks much better. And this goes up. Okay, So now what we can do is we can just follow our pattern. So this was up, this is down, then this is going to be up again. Okay, so let's see, down, up, this will be down. Then we're at up again, down again, up again, down again. Oh boy, I have some drawing to do, don't I? But you get the idea. So if I were to just try to quickly draw these in, it's gonna be messy. I'm not even gonna do the arrows from now on. Oops. Okay, you get the idea, right? All right. There's a lot of them, right? And then this one goes down and down. Okay, so that's the process. Now, what do you need to have on your graphs? Well, I technically just need to see your asymptotes, and then I need to see these blue curves where they belong, right? But if you need to graph your sine curve a couple times to shift it with a period change, whatever, you go right ahead. Just make sure that it's clear what your final curve is. And just one last piece of advice, remember to not shift your sine or cosine curve vertically until after you have found your asymptotes. Okay, so do the horizontal shift, do a period change, then find your asymptotes, and then do any vertical shift that you might need to do for your final curve. All right, it's been wonderful. Hopefully this wasn't too bad for you guys. Good luck with all your graphing.